Okay, good morning. Today I will try to keep the lesson short. I just want to finalize what we started about arithmetic progression, and most of the time you will get the time to practice on yourself. If you remember, last time we talked about arithmetic progression, so we learned that an arithmetic progression is a sequence of numbers. Okay, and then you can continue sub to an. But when you use the arithmetic progression, it means that it actually terminates. It will not continue forever. So assume that this is your list and the number that you always add to get the other one. So you remember what was the definition of arithmetic progression is that each term is obtained from the previous term by adding one constant term to each one of those terms. So I add d to a1, it gives me a2. I add d to a2, it gives me a3, and I continue this. And I realize that there is a formula if I want to calculate the nth term of this arithmetic progression. It is very simple. It is just the first term plus n minus 1 times d. The d is the common difference. We also learned something about the sum of these numbers from the first term to the nth term. Yes? And then that was denoted by Sn. So Sn means the sum of the first n terms of the arithmetic progression. Or in other words, this is a1 plus a2 up to an. Or if you want, you can write it as a sigma notation. So sigma of any letter that you like. So for example, k goes from 1 to n. And we also learned that there is a formula for Sn. And I wrote two versions of Sn for you. The one that we just found it using the proof was n over 2. N is this number that you see here, multiplied by the first number in my list, plus the last number. This was one version. Yes. And then I told you that usually the information that are available for us is just A1 and A1 and D. So it is better to write this in terms of A1 and D. So in that case, instead of AN, I put this expression in. So I get a second formula. So this A1 in this will be added to this A1. So I will get 2A1 plus n minus 1D. That's up to you which one you want to use. So these are the formulas we had so far. Usually, I actually gave plenty of a diversity of examples for the first one, but I didn't have that much time to give you some examples regarding the second one. Let us just try to give more examples about this and new topic as well. So might be one thing is to calculate famous sums. Yes, for example, one of the famous sums in mathematics is that what happens if I add the natural numbers from the first number to some point. Yes, for example, I want to answer this question. Is there any formula for this? So remember, this formula only helps if the terms of your sum form an arithmetic progression. Otherwise, it is useless. Okay, so the terms of my sum here are 1, 2, 3, 4, etc. So that's an arithmetic progression in which the common difference is 1. So can I use this formula for this case? The answer is yes. And how should I use it? So the answer is very clear. N is the number of terms that you are interested here. In this case, I have n terms, so it becomes n divided by 2. The first term is 1. The last term is n. So that's a very famous formula in mathematics. If you add numbers from 1 up to n, the formula is this. So it is important to, I think it's good to remember this formula. So if I want to write it a little bit different, I put n plus 1 divided by 2. Yes? So we actually got a formula. So what do you think about if I add even numbers? So what do I mean? I mean the first even number is 2, the second even number is 4, and then I have 6, then I have 8, and then let me continue my list until I reach to the nth term. So which is what? 2n. So just let me review things. Do you think that this formula that we discovered here is useful for this sum or not?
Yes.
Why?
Because it's the second one is just the first one multiplied by 2.
Okay, so that's a different story. But is this formula, can I use the formula directly here? Yes, because the terms are involved are 2, 4, 6, 8, up to 2n. Do these terms form an arithmetic progression? The answer is yes. The first one is 2. I add 2 units, it becomes 4. I add 2 units, it becomes 6. So that is the sum of an arithmetic progression. Whenever you are dealing with the sum of an arithmetic progression, that formula might be useful. Yes? Okay, of course, what you said is also correct. So it means that you really, if you calculate this, for calculating this, you really don't need to use the arithmetic progression formula. Can you immediately tell me what the answer is? Yeah, by the method that you mentioned, it is much easier to immediately understand what is the answer to this. Yes?
Is it simply the formula not divided by 2?
Yes. Why is that? Because this sum, each term in this sum is 2 times larger than this sum, 2 times larger than the corresponding term in this sum. So one way of answering say that it is not hard to see if this number is equal to this sum is nothing except this sum multiplied by 2. Okay, if I multiply this by 2, 2 becomes 1 becomes 2, 2 becomes 4, 3 becomes 6, n becomes 2n. So I also multiply this by 2. So it is clear that the answer to this problem should be n times n plus 1. Yes or no? Okay, but let us follow the formula. So what is the formula? The formula tells me n. By the way, what is n in this case? N is the number of terms involved. I have started from 2 and I am going up 2 units at a time and I reached a 2n. So how many terms are involved? How many terms you see here? This is the first term. This is the second term. This is the third term. So which term is that? Nth term, yes? So the number of terms involved is n, so you not write n over 2, and then you write the first term, which in this case is 2, plus the sum of the nth term, which is 2n. But you realize that a 2 can be factored out. And this 2 and that 2 are gone, so you get n plus 1 times n. So that is the sum of the even numbers. Okay, let us talk about the sum of odd numbers as well, but that is, let us discover a pattern a little bit. So if 1 is just 1, if I add 1 to the second odd number, 1 and 3, it becomes 4. If I do this for 3 first odd numbers, it becomes how much? 9, and then it is 1 plus 3 plus 5 plus 7 is 16. So you see all of these numbers are complete squares so far, yes? But do you think it's a coincidence or this pattern will continue? It is interesting, yes. Though if you add only odd numbers from 1 up to some point, it seems that I am getting a complete square, yes. So this is not a coincidence. We can prove it using the formula. So for example, I start from 1, the next number is 3, the next number is 5, and then I continue until I reach to 2n minus 1. Okay, I want to answer this question. Again, can you tell me how many terms are involved? How many? N again. So it becomes n over 2. And then what I have to take? I have to take the first term, which is 1, add the nth term to it, which is 2n minus 1. And then you see that this minus 1 and that 1 are cancelled. So what I get is n over 2 multiplied by 2n. Then this 2 and that 2 are cancelled. And as we were able to see, it is not a coincidence. So the answer becomes n squared. So it means the sum of the first n terms of the odd sequence consisting of odd natural numbers is always a complete square. So that's also good to know. So 1 plus 3 plus 5 up to 2n minus 1 is actually n squared. Okay, let me write another example. So consider an arithmetic progression, an AP, okay? If the sum of the first term, if the sum of the first uh, 20 terms is 903 and the seventh term is 27, determine the sequence, determine the AP. Of course, determining the AP means you should be able to write the terms, but you know that what you need to do is just to find a sub 1 and d, because if you know the first term and you know d, you can generate the sequence yourself. So in principle, such a question means find a 1 and d. Okay, so that is a very simple problem, but it's a typical standard problem in this topic. Yes, so you know is the sum of the first 20 terms is 903. So if I want to translate this sentence into mathematical symbols, it means S sub 20 is actually 903. So that is I can write it with because of that piece of information, and then I have one more piece of information. Of course, you know that in order to understand, to determine the AP, you need to have two pieces of information in hand. One of them is A1, the other one is D. So this is why they have to give you two pieces of information, and this is why they have provided us with two pieces. One is the sum of the first 20 terms, and the second one is the seventh term, yes? So this means, for example, A number 7 is 27. Oh, okay, sorry, I think this is not the first 20 term, otherwise it will not work. This is first 21 terms. Yeah, it becomes a decimal and it doesn't work. So let me make sure that the numbers are correct. 903, 27, yes, that's correct. Okay, so let us try to use this one first, because we already know what to do with this. A7 is given to be 27. And this means that instead of A7, I can write A1 plus how many D's? 1 less. This is 7. I subtract 1 from it and then multiply it by D. So this becomes 6D is equal to 27. So that is one equation. And I hope that you agree with me that in this problem, the second version is more useful, yes? Because I have Sn, I want to say something about A1 and D. So instead of using this version of the formula, I will try to use the second one. So S20 is equal to 903, this implies that instead of S20, I use this formula. So 20 is playing the role of n. So 20, so let me write everything. So 20 divided by 2, and then I have 2 times A1 plus 20 minus 1 times D is equal to 903. And do some simplifications. This is just simply, again, I made a mistake. I start solving it with this one, sorry. I change it to 21. You need to inform me if you see something. So this is 21. So that is the bad thing here now. I have to change everything. I hope that I'm not confusing you. So that I changed the question. I forgot to change this number. Okay, so what do you think we should do? I would recommend you not to divide this. So you see that a 2 is coming from here, and then 21 minus 1 is 20. So 2 and 20 have 2 in common. I can take it out. So try to do the algebra simpler for yourself. So it doesn't matter at the end, but it is better to simplify things. So here, this number is nothing except 20. Between these two, I factor a 2 out. And then this becomes just a 1. This becomes 10D. And on the right-hand side, I have 903. It is, by the way, important to do it in that way, because if it comes in that part that calculation is not allowed, calculator is not allowed, then you have to do it in that way. If you want to divide, you will be able to solve it, but it becomes much harder for us. So this 2 and that 2 are now cancelled. So what I get is 21. A1 plus 10D is equal to 903. Do you think 903 is divisible by, because it is, if I divide by, it is clear it is divisible by 3. So by the way, you really don't need calculator. So this becomes A1 plus 20D. It becomes 903 divided by 21. Might be you think it is better to multiply in, that will also work, but let us see if it works. This would be better. So I divide by 3, it becomes 7. I divide this by 3, it becomes 301. Okay, what about this one now? Is it divisible or not? 4. It's not divisible, yes?
It is.
Is it?
Yeah.
What is that?
301 divisible. Divided by 7 is 43.
Okay. Yes, you are right, 43. Okay, so then I have 2 equations and 2 unknowns. Okay, so let me write it now. So I have a system here, A1 plus 6D is 27. And the other one we got is an A1 plus 10D is equal to 43. Then I have to solve the system. And this is also very simple. For example, if I just multiply the first one by -1 and add it to the second one, minus A1 and A1 are cancelled. Minus 6D plus 10D becomes 4D. Minus 27 plus 43 is 16. And then you can simply find D, which is 4. And then when you have D, you can plug it into the first equation, for example. This becomes 24, and A1 becomes 3, yes? So I realized what is my arithmetic progression. Determine the arithmetic progression means finding these 2 numbers, because now I know the progression. The first one is 3, The second one is 7 because I found that these should be 4. The next one is 11. I don't know. The next one is 15, and this will continue. Yes, is that clear? Okay, let me give you another example. That's also a good example here. Determine the sum of all 3-digit numbers whose remainder remainders on the division by 11 is 7. So I hope my English is understandable here. So what I mean that you need to go and find all 3-digit numbers so that when you divide each one of them by 11, the remainder is 7. And then I want you to add them all up. And then I want the answer of that. So is that clear? So among all 3-digit numbers, there are some of them with this property that if you take it and divide by 11, the remainder is 7. There are some of them. I want you to find the sum of all of them. Okay? Yeah, I will wait a little bit for you to see how you can solve this problem. Okay, could you solve it? Yes, Kenshal, how could you do that?
So I said that let's think of all of the 3-digit numbers. It starts with 100 and ends with 999. And then I found the first number which was divisible by 11 and got us the remainder of 7, and that number was 106.
Yes, agreed. So what Kenshal is saying is that the list of all 3-digit numbers, of course, this will start from 100 up until 999. But I am not interested in all of them. I am interested in all of them, in those that have this property that when I divide them by 11, it becomes 7. So it means that you need to find the smallest number in your list and probably the last number in your list. Let us see if it works or not. So what is my smallest number in the list? So if I want to divide by 11, the remainder is supposed to, that number that I am interested in should have this form. When I divide it by 11, it gives me a quotient, which I don't know, but the remainder is supposed to be 7. Okay, for example, it is clear that if I put 8, so 8 times 11, it becomes 88, plus 7 is 95. 95 is not, it has this property, but it is not a 3-digit number. So the first number that I can assign to Q is 9. When I put 9 for Q, it becomes 99, and when I add 7, it becomes 106. So it is clear that 106 is the first number in my list. Okay? And by the way, what is the next number? Do you remember I assigned 9 here? So I have to assign 10 now, yes, because I want to go to the next number. So if I assign 10 here, it becomes 110 plus 7, so it is 117. I hope that you see that every time that I add 1 unit to Q, it will add 11 units to actually the previous term. So it means that that is good because it is forming an arithmetic progression in which the common difference is 11. Yes? So that's the point. So the next one is definitely what? 128. And then I have to continue this list and see that when it ends. Okay, so that is also probably you need a little bit of calculation or whatever. So what is the, for example, so I should actually stop. If I give 100, then it becomes 1100, which is above being 3-digit, yes? So what is the last number in your list? So if you want to use the calculator to calculate this, so this is the trick that I use if I want to use the calculator. I just equate it to 999. I know that Q should be an integer, but forget about it for the time being. I move it to the other side, and I would say that this number minus 7 is 992, and I divide it by 11. Okay, can you do this by your calculator, please? What is the answer? Is what? 19, 90 point something like that, yes? So, and I take the integer part and then again multiply it by 11 and then add 7 to it. So the integer part, so it becomes 11 times 90 plus 7. So that is the last number. This is the way that I find it. That it doesn't matter. You can find it in any way that you like it. But I recommend you to try to do it in that way if you have the calculator.
No, but that is 99.
99, yes.
So it's 91.
What? Yeah, it is 91, yes. Yeah. So this is, no, it's not 91. I did it correctly.
No, how is it?
Yes. Because if you put 91, it goes beyond that number. So you have to put the number less than that, yes? So this is 90 point something, okay? But Q should be an integer. If I go to 91, I go beyond 1000, but still I want to be below 1000. So I have to take it 90. And if you multiply it by that, what happens? This becomes 990 and 997. Yes? And this is it. The only hard part of this problem to understand what the problem is talking about, and then you have a list of numbers which form an arithmetic progression, then you add them. So which formula do you want to use? For example, Sn, if you use Sn, n over 2a1 plus an is good. But you need to understand how many terms are involved. How many terms? No, why 80?
Which is 997 is equal to 106. And we know that the distance is 11. The difference or not distance.
So if you don't mind, I recommend you to calculate n, okay, rather than guessing it.
We get the difference in the equation. Because we have
Yeah, exactly. So what I'm saying is that an, you know this is an, this is a1, and you know that is an. So an is 997, but an has a formula which is a1 plus n minus 1d, which is 997. a1 is 106, n is missing, d is how many? 11. And solving this will give you n. Okay, so let us just do that. So this becomes 11 times n minus 1. I move 106 to the other side. It becomes 1, 9, and 8. And then I divide everything by 11. This becomes 80, 81, yes? Yes? And then n becomes 82. So the number of terms involved is 82 terms. Another way is also clear. Do you remember how did I get 107? So 106, I assigned which number to Q? Do you remember? I assigned 9. So this corresponds to Q equals to 9. The next one corresponds to Q equals to 10. And then what was Q for the last one? 80. No, the Q for the last one was 90. Yes? And then I can ask you how many numbers you see, 9, 10, 11, up to 90. How many terms are there? From 9, 10, 11, up to 90. How many terms are involved? Pardon? 82. Because if you write 90 minus 9, I remember if I told you several times that this is not correct, it gives you 81, but you're also including those numbers, so you need to add 1 unit. So it is 82. But I think this is the safest way to calculate. And now everything is ready. So instead of n, I put 82. Instead of the first term, I put 106. Instead of the last term, I put 997. So that's it. So Sn becomes equal to 82 divided by 2, and then 106 plus 997. So this becomes 41 multiplied by, this is 3, this is 0. What is that? It's 1103, yes? You need to multiply this. So I don't know if I have the number here. No. Do you have the number? You can calculate it, of course, it doesn't matter. Okay, any questions regarding this problem? But I also give you one more example and the lesson is finished now. Sometimes using the formula becomes algebraically very hard. I want you to understand this. So this is the question. Example, prove that in any arithmetic progression we have this: s sub n minus 2a sub n minus 1 plus s n minus 2 is d. Okay, the reason that this problem is interesting for me because I see the author as actually is killing himself to solve the problem. It's easier to solve the problem in a very short way. So if you want to use actually use the formula, so the method that the author is writing is just putting the formula for each one of them. And then it becomes, it's possible of course, but you have to do a lot of algebra. So let me just describe what is one way of doing it. So you can use the formula here on top. Yeah, here, this version of Sn. So this is something I want to prove. So I start from the left-hand side, which is more involved, and try to simplify it. Instead of Sn, of course, it is clear I can put this expression in. So this becomes n over 2 and 2a1 plus n minus 1 times d. That's good. And then I will do the same thing for the other ones. So minus 2 multiplied by. What is s sub n minus 1? S sub n minus 1, it means that go into this formula, replace every appearance of n with n minus 1. So then this becomes n minus 1 over 2, 2 times a1 plus n minus 2d, yes? Yes? And then plus s sub n minus 2, it means that I will do the same thing. I will change every n to n minus 2. So then it becomes plus n minus 2 over 2, and then I have 2a1 plus n minus 3 times d. And then you have to do a lot of calculations, and of course it will work. What do I mean? So for example, you multiply d in, you multiply n over 2n, you simplify this 2 with that 2, you multiply everything. And after that, hopefully, if you don't do any mistakes, you will get that this becomes equal to d, and that's equal to the right-hand side. Yes? This is the method that they are actually presenting it here. But there is a much, much easier way to do it. Can you see that? Any idea? I can give you a hint, yes? So the left-hand side, write it like this. First of all, let us see if this is true or false. So here I have Sn, here I also have Sn. But let me multiply this minus sign in. What will happen? It becomes minus s sub n minus 1, another minus s sub n minus 1 here. So it becomes exactly minus 2 times s sub n minus 1. And then minus times this minus, it becomes plus. So what I have written here is exactly valid, yes? So it is correct. So I have just deformed this into this. I had something in my head that I did it like this. Okay, now can you tell me why this is useful? Yes? These two, there are no both sides. This is one side. Left-hand side is equal to this plus that. You mean they are equal? No, they are not. Even if they are equal, then it means that this will become 0. If your theory is correct, yes, but this claims that this should be d, and the author himself or herself was able to prove it like this, So this is not 0. But what is the answer to this? Okay, think about this. Do you need a formula to answer this? Of course, you have your formula, but you don't need any formula to answer this. What is the answer to this? Sn, yes? An. That is just an. Because Sn means you add from the first term yes, from here to here is Sn, but from here to here is what? Sn minus 1. So now if I subtract these two, the answer becomes An. Understandable or not? So the first pair of brackets is nothing except an. Then minus, what is this one now? Exactly similar, yes? What is Sn minus 1? So this becomes a1, a2, up to an minus 2 plus an minus 1. From here to here is Sn minus 1. From here to here is Sn minus 2. If you subtract them, what is left? An minus 1. And then what is an minus 1? A term minus its previous term. So that's just d. And that's the finished, yes? So this is a better way to do it. Okay, sometimes it is good to understand what is the meaning of Sn. So you see that its calculation is much easier if you pay attention to what is the meaning of the symbols rather than just doing it using the formulas. Of course, if you use the formulas, it also work. That will also work, but it takes quite a time to actually simplify that. Okay, any questions? Okay, so I have already updated the Google Classroom, so nothing I will add. So if you are behind, you can start working on them, and if you have questions, please let me know. Next time we will start the geometric progression. Okay? Thank you.